Okay. Okay, so shorter lesson today. We'll knock this one out pretty quickly. The first one is just an example of when you're given computer output, because computer programs for statistics do pretty much everything that we do, all the procedures, including confidence intervals. So there was this study of 102 decisions, our sample size, made by the Nebraska Board of Parole, and the cases were representative of all the cases that came before the board. So they made a z-interval for proportion, so they've done a confidence interval with 95% confidence, and they're using inequality notation instead of interval notation. P of parole is the percentage or the proportion of parole is between 56.1% and 62.5%. So all the work is done. We just have to conclude. We have to interpret. So we have that sentence that we write. We are 95% confident that between 56.1% and 62.5% of parole cases are decided by the Nebraska Board of Parole. I really need to stick that word all in there again. I keep leaving it out because our confidence interval is always about what we're predicting for the entire population of cases. Okay, so just practice writing the sentence based on the computer output. Last but not least, you are also, besides interpreting a particular confidence interval in context, expected to be able to explain what you mean by being 90% confident, 95% confident, whatever. So, it just helps if we have some sort of a physical thing to connect to. So let's pretend that we have another tub of beans, different tub than we've had before, and we're just going to pretend to pass them around, and each person in the class is going to take a sample. Let's say that this particular tub, we'll just pretend you don't know, so we're passing it around, but this particular tub has 18% white, okay? But you don't know that when you first pass the tub around. So you pass the tub around, and Ryan takes a sample, and he uses his sample p hat to construct a confidence interval. So p hat plus or minus z star times the square root of p hat over q times q hat over n. So Ryan makes a confidence interval. So he has his own p hat, and then he has an interval to the left and to the right. So he has some interval that should be equally spaced, by the way, that describes his prediction of what's in the bowl. So he passes the bowl to Judson, and Judson takes a sample, and he has a sample p hat that's here, and it's smaller than Ryan's was, and he constructs a confidence interval, and his confidence interval is between here and here, and there's some imaginary number line down here under it that's lining up with these percentages. Then we pass the bowl to Morgan, and Morgan takes a sample, and her sample p hat's here, and she constructs a confidence interval. And so her interval predicts that the proportion of white beans is between here and here. So we keep passing the bowl around, and people take samples and make p hats, and some of them are unusually low, some of them are unusually high, some are wider, some are narrower, and everybody in the class gets a p hat and creates a confidence interval. So you get all these confidence intervals floating around for p hat that you personally draw out of the bucket. Now we're only going to draw 20 something of them out of the bucket because that's how big the class is. But after we pass the bucket around and everybody makes a confidence interval and we graph them, Miss Rice finally reveals this number line down here and says, okay, right here is where 18% is. And 18% of that bucket is white. And so if we sort of follow that line up, we can tell that Ryan's interval captured the true proportion of white beans, and Judson's captured it, and Morgan's captured it, and this one captured it. But this one right here, whoever made this interval, this one was an unusually low one, and this confidence interval doesn't capture the true proportion. So this one might have been 10% white, and it went from 7% to 13%, so it didn't quite capture the 18. So this dude's an oddball, and this one right here was unusually high. And this interval didn't capture that 18%, but everybody else's intervals did. So because there's variation from sample to sample, if you look at all possible samples, and this is just a few, but if you look at all possible samples and their associated confidence intervals, 95% of all possible sample confidence intervals should capture this 18%. And the other 5% should miss it. That's what 95% confidence means. It means that out of all possible samples, if we make confidence intervals with all those possible samples, 95% of those intervals should actually capture the true percentage of white beans, and the other 5 will miss it. So when we say we're 95% confident, it means we think that we might have one of those that actually does catch it, and we're 95% confident that we did, because we know that there's a 5% that doesn't capture it, and we might still have one of those, so we're never 100% confident that we've captured the true proportion. The picture of that in the textbook, well, I'm going to skip, hold on, let's do this first. So big ideas are that a few samples will have a p-hat that is unusually lower or higher than the true proportion of white beans in the tub. So we saw those two in the picture that I just drew. Most p-hats will be within 2 standard deviations of the mean, about 95% of them to be exact. Well, to be close to exact. If we collect all possible samples of beans, 95% of them should have confidence intervals that capture the true proportion of white beans in the tub. And in the book, you'll find this picture. So it's the picture that I just drew turned sideways without the ends and the p-hat on it. But for any one of these little lines that we're seeing here, we have the confidence interval reaches from here to here, and halfway between, that's a sample p-hat that somebody drew. So they're just turned the other way to make them fit on the paper. So if we look at all the possible confidence intervals, which this isn't all of them, this is just some sample ones, notice that this one didn't capture the true proportion. This mean right here, mu, that's the true proportion of white beans in the tub. That one missed it, that one missed it, that one missed it. The rest of them all contain that true proportion. If we could get all the possible confidence intervals that exist based on all the possible samples that exist, then 95% of those confidence intervals will contain that true proportion. And that's what 95% confidence means. Okay, so this statement here, let's try to commit this statement to memory, because that's what you're going to have to spit out every time you're asked this question. You'll run into that in a couple of homework problems, and you just need to be able to spit out that statement. All right, the last homework, or your day 3 homework, is on the next slide, and today's a good day to get that done and catch up on anything you might be behind on. And Monday we'll wrap things up and just see what we're still having questions about, and Tuesday will be quiz day. Have a good weekend.